We are live. Welcome everyone to our second webinar to talk about some of the big things that we have coming. Well, it says something big is coming, something big is actually here. So today we're going to talk about some of the improvements that we've made on our hardware and also our latest major release of our Oxygen software, Oxygen version 8. Joining me today, I have Malik Mukdadi, who is our latest addition to our applications engineering team. And just like to bring him on board and have him say hi to everybody. All right, so during our webinar here, if you have any questions, please feel free to put those in the chat. We'll answer those as we can. And if we don't get to those, we will certainly send you an email with the best answer that we can provide to you. Also, during our webinar, we're going to have a couple of polls that'll come up. We ask that you guys please answer those and let us know how you're using our systems, what you're doing, and just give us a general sense of who's on board and participating in our call here, or our webinar. All right, so getting into it and getting started, we're going to talk about our latest hardware improvements that we've made, our software updates. Like I was saying, we're going to talk about our Oxygen version 8, the latest major revision of our Oxygen software. And then we're going to have a product highlight, which I'm super excited about. Some really cool stuff coming down the pipes are actually already here. And let's roll into it. So our hardware. So we have officially released our DEWE3A8 and our A12 platforms. These had their contemporaries before, the DEWE2 versions, but with these, one of the major improvements you would see as a user would be the evolution from the PXI backplane to a PXI Express backplane. So that is a 10x data throughput improvement. So before, those of us who know, PXI is a 10 megabyte per second throughput, but the PXI Express, that's 100. So that's where that 10x comes from. Each of these units are for the higher channel counts. So we have 8 slots and 12 slots. One of the things I love about our part numbers is that they make sense. So you can see there in the part number DEWE3A8, that's an all-in-one with 8 slots, A12, 12 slots. Both of these come with integrated touchscreen display. And of course, they fit both our Trion 3 and our Generation 2 Trion cards. So all of your old Trion cards, if you do upgrade to a DEWE3 chassis, all those original Trion cards you had will still work. Joining that part of the family that was also modernized into our Generation 3 platform is our DEWE3A8 PA. So those of you who don't know, we do power analysis and we do it very well. One really cool thing about this one is it has all the cool features you would see with the standard DEWE3A8, except this one actually has the integrated transducer power supply, which is really nice. We are a hardware company. We pride ourselves in our hardware, and we want to make sure that you have that quality hardware along with the ability to use it effectively and simplify your overall testing that you're doing. So this one actually comes with that integrated power supply, so no extra power supply box or no extra equipment needed. You can take this all in one unit, take it with you, and take care of all of your power analysis needs. And then, of course, as well, because we do pride ourselves in our hardware, like I said, and the modularity aspect of that hardware. You can pull in not only just power, you can pull in any other of our Trion or Trion 3 cards. All right, now I'm going to pass it over to Malik, who's going to talk about some of the improvements that we've made to our Trion cards. Take it away, Malik.
Thanks, Tyler. So joining the new DEWE3 chassis, we've also have a Trion 3 module that is an upgrade from the Trion 16XX module, if you're familiar with it. This is the Trion 3 24XX ACC LV module, which is meant to measure voltage or IAPE sensors. It comes with 6 analog input channels with BNC connectors in 2 flavors or 2 sample rates, 200 kilosamples per second or 2 megasamples per second. It's a 24-bit ADC channel for every channel. Just as Tyler was mentioning, the naming convention is very easy to follow. The 24 stands for that ADC, and the XX will stand in for your sampling rate. So ultimately, we have 4 different options that you can select from. As I mentioned before, with the sampling rates, either the 200 kilosample or the 2 megasample sample rate per channel, or you can go with the ACC or the LV version, which stands for accelerometer or low voltage version. The ACC version has all the same features as the LV version does, except it also accepts a IEPE input for your accelerometers. In conjunction with that, we've also released versions of these boards that are a combination with the 8-out-8 card. So the beauty behind this is that typically whenever it comes to processing all these multiple modules in one chassis, everything will have to go through the operating system in the back end. However, with this new combination card, everything is processed through the FPGA, through the hardware directly on the module. And so you get rid of or remove any latency that can be caused through operating system, drivers, Windows, you name it.
Yeah, that part's really cool, Malik. Being able to integrate those 2 FPGAs so you get essentially a clean, full pass-through of that data as it's streaming into that channel. So no going through the Windows operating system, like you said.
Yeah, yeah. And to add on to that, we've also improved the specifications of the board as well. So I won't dive into every single specification that we've improved on. You'll be able to reference that in our Try-On technical manual that you can find in our customer care center. However, some key features or keynotes that I really want to point out is the accuracy. The voltage input accuracy is up to 0.02% of the reading, plus minus 0.02% of the range, coming in with 20 microvolts of noise. So the total error is very, very low. And the isolation voltage as well can go up to plus minus 1,500 volts peak to peak. This is channel to channel and channel to chassis. So you really have full isolation with every channel in this board. And then another big update or improvement that we've made was to the channel-to-channel phase mismatch. So previously with the 16XX board, we were seeing about 30 nanoseconds of channel-to-channel phase mismatch. Now with the 24XX, we are seeing down to 10 nanoseconds channel-to-channel phase mismatch. Adding on to some other highlights is the flexible filtering that we now offer. We've added in a FIR low-pass filter onto the board. This has allowed us to achieve a lower noise floor and allowed us to even achieve some anti-aliasing features that I want to dive into here. So previously with the 16XX board, right, the filtering that we had on board, you can see the roll-off here for the filter and the gray waveform. We were seeing after the Nyquist frequency that we weren't really having much a steep roll-off, if you will, right? And this was causing a lot of noise and really a lot of aliasing. As you may know, it occurs after the Nyquist frequency. So with this new FIR filter, we were able to achieve a much steeper roll-off. That's that blue waveform that you see here, where we're achieving 90 decibels of attenuation before that Nyquist frequency. So this is I want to say programmable, but this is, you can change it in the software as you need. If you find that yourself having to deal with a lot of issues with aliasing, this board has that opportunity for you to fix that. On top of that, we have the IR filter from the 16XX board in conjunction with it, but we've also improved that. So now it accepts up to the 10th order. Now, I really want to dive into the noise improvements that we've made here. So I have 3 waveforms here for you guys. The yellow waveform is the 1620 board. The orange one is the 2402, and the green one is the 2420. So you can see immediately, even with a lower sampling rate, the difference between the noise of the 1620 and the 2402, even though it has 10x less sampling than its older generation, its predecessor, it still has a much better noise floor, or a decently better noise floor, showing the improvements that the hardware has really brought about. And if you want to make a very direct comparison at the same sampling rate, this is that yellow waveform versus the green one, we're able to achieve an ultra low noise floor below 160 decibels. So we've really been able to maximize and utilize all the bits in that ADC so that you can get as much resolution as possible here. On top of that, we've also made some hardware modifications to the board itself. So this is that LED indication light that you may have noticed in the picture. Here I've zoomed in on it so that you guys can see it a little bit further. In the LV, the voltage mode, you only have two indications, right? And this is green and orange. Green saying that the input signal is within the range, the expected range you want, whereas orange will be an overload detected, it's out of range. However, in the accelerometer version, the IAPE mode, we have these same two indications for that normal condition or overload detection, as well as two more modes where the LED would be off, showing that there's no sensor detected, maybe it's an open circuit or it's broken, and then a red showcasing the short circuit on the sensors detected. This feature is also included into the software, either in the channel section so that you can easily see the status of every channel that you have, or if you really want to see it on your measurement screen, you could use that using the saturation meter per channel and then see the indications directly all in one place.
Awesome. Really good stuff. So like we were saying before, we are a hardware company. That's what we pride ourselves here at DEWETRON. So we want to make sure you have the highest quality hardware, and that's where we really like to start, or where we really like to make these improvements to make sure that you have exactly the testing infrastructure that you need. So we talked about, some of the changes or some of the improvements we made to our chassis, with 3 of our chassis now going to the Generation 3 platform and utilizing PXI Express. So we talked about the speed increase and throughput there. We talked about the increased sample rates that we have with some of our cards, along with that increased resolution you get with the improved ADCs. So going from that 16 to that 24, that gives you over 250x resolution inside your data and information that's coming into your system. The filtering, also really cool. And Malik was saying this, so that filtering happens at the card. We all know the old adage, garbage in, garbage out. We filter all of that junk out before we even digitize that data, because why would we do that? There's no need to digitize the junk. We want to make sure you have the quality data. And we talked about the dual functionality as well, with integrating those 2 cards with the AO card to be able to act as a clean pass-through, essentially melding those 2 FPGAs together. And then my favorite, the lights. So this seems like it could be simple, but I've been asked this specifically by other DEWETRON users out in the field. It's like, hey, I'm doing this really large, I got this really large test going on with 1,000+ channels. And in order for me to troubleshoot, a potential sensor in the field not connected properly, I have to start checking all these sensors. Now you can look at either the faceplate on the actual card itself and see if there's any, shorts or anything happening with it, or you can look directly in your Oxygen platform as well, into the software, to see if any of those devices out in the field aren't connected properly, or if there is an issue. Saves you a ton of time, saves you money, and just makes your lives and everybody's lives a lot easier. Okay, so now let's talk about Oxygen version 8, our latest major revision of Oxygen. Malik's going to cover some really cool quality of life enhancements that we've made, time savers, all kinds of cool stuff. All right, Malik, it's all you.
All right, let me dive right into it. Let's see here. Okay, so I'll be covering a lot of the big updates that we've made to the new major release, 8.0. So quick little table of contents of what we'll be discussing about today. First will be Oxygen Go. Well, actually, I think we're going to leave that as a surprise. So I'm going to push that towards the end. I don't want to ruin what we've planned for you guys yet. We'll be covering gPTP support, XCP data transfer improvements that we've made, additions to SCPI interface, new feature known as like channel tags. This one is really cool, actually. And then some more UI or customer-facing, I guess, consumer-facing features to make things easier, like instrument grouping, a new export type, and some further improvements like offline usage of scopes and whatnot. So nevertheless, let's dive right into it. So first and foremost is gPTP support. What gPTP is, it's a synchronization. It's not a separate protocol from PTP, but more of like a subsidiary or a specific profile of PTP. The main difference between it is the communication and how it's transferred. PTP typically is done through layer 3, which uses IP or UDP. gPTP is mainly on layer 2, so think Ethernet. The use case for this is for people who have really strict specifications, engineers who might have to have a more like high precision or low latency when it comes to their synchronization. The options works just as PTP does. So you have your connections here for your in and out, for your client and your master. And let me show you guys how you can go and configure that into Oxygen. So you'll want to open up your Oxygen Net tab. And you'll go over to your synchronization settings as you normally would. I've already turned off the auto setup so that I can go into PTP. And as I mentioned, right, gPTP isn't its own protocol, it's part of PTP. So we have this profile option here where you can select between standard or gPTP. So this fits your use case. Everything on the hardware is ultimately the same. It's just more so the software side of things that you want to make sure to configure. Next, we'll talk about XCP data transfer rates and the enhancements that we've made to it. So previously, we were only able to achieve a maximum data transfer rate of 10 kilosamples per second. Now we've improved this up to 2 megasamples per second. We've made it so that you can choose options. It's discretized into options of 50 kilosamples per second, 100, 500 kilosamples per second, or 1 and 2 megasamples per second. Now, in terms of the transfer type, you can choose and select between raw values or average values. And we have tested so far up to 16 channels simultaneously at 2 megasamples per second to ensure that you get this max data transfer rate. Now, to add on to that, this is just the maximum that we've tested in-house, right? We did not push much further because we did not see, we saw that 16 channels was sufficient in our case. However, if you do have an application or a use case where you might need more than 16 channels all running at the maximum speed, feel free to reach out to us and we'll work with you directly to ensure that we can find a solution.
So, Malik, that's not a typo. Is it 2 megasamples per second?
No, Tyler, no, it's not a typo at all.
That's a 200x increase in just overall throughput or data stream capability. That's crazy. So I would suggest that anybody who maybe felt that XCP in the past wasn't a viable tool for you because of the data transfer, I would consider revisiting that with these new enhancements we've made with version 8.
Yeah, and we've made sure that it's pretty robust, right? When you're running multiple channels simultaneously as well. So it's been working very well so far with us. And some more additions that we've made, aside from that is SCPI. So this one is a big one that I like. So as you guys may be familiar with SCPI, you are able to automate Oxygen through your SCPI commands. We've decided to add some extensions in terms of the commands that you can query, that you can automate Oxygen with. covering measurement screen control. So this is with the actual measurement screen, selecting, adding, removing, or querying active measurement screens. So being able to navigate between these screens like that. We've also added some more management control to instruments, as well as some more instrument-specific controls. So this covers, adding, removing instruments, just like you would normally here, being able to change the position, the size, being able to change the channels that you've assigned to it, whether you want to add, remove, or query some there. And then we've also added, like I mentioned, the control for those instruments specifically. So this is, the scaling that X and Y axis, messing around with the cursors, whether it's activating, deactivating it, or moving that A and B cursor. And then that, comes along with the statistical data that you may want to query, your max, your min, your averages, so on and so forth. We do have some more additional functionality that we've also added for SCPI. And these are just more so user interfaces. So the saturation display, messing around with that orange time cursor. And I think a really important one, right? Saving these changes to a loaded DMD file so you don't lose that. And then being able to work with that storage space, or being able to see the estimated remaining recording time, really tying in the whole organizational aspect of this. We've also introduced a new feature known as channel tags. So I'm just going to jump right into showing how the channel tags works as I explain it, as I think this visually will make a lot more sense as to why we wanted to focus on this. So what channel tags are is a new way of organizing or being able to identify the type of channels that you're working with. So typically, you guys may be familiar with working with the analog, digital, counter, or CAN channels, but now you can start adding in some of your own personalized tags depending on your systems. So the idea that I started to implement here, albeit it's not very creative, is having systems and subsystems. In my case here, I have devices under tests, and I've been assigning different types of channels to different types of functionalities, whether they're an IAPE sensor, if it's specific with temperature, or if it's specific to a subsystem like a DUT under test. So the way to add these tags is quite simple, actually. You want to select the channel that you want to work with, that you want to tag, and then you'll find this tag button up here in the top. You'll be able to type in or select from tags that you've already had, but let's say you want to add a new tag. I can go ahead and add in .4, and so this will be a new tag that I create, which I'll be able to change the color coding so it matches something that's different than the others, and you'll see that the channel, the CAN channel I selected, now has that tag. This also allows us to filter by tag, just like we would with any other channel types. Now I can specify a certain tag that I've created. So here I did .4, as you see here. Okay. The next big thing that we also introduced is instrument grouping. So the idea behind this is to be able to utilize multiple different types of instruments and being able to have them come under a specific group, depending on your guys' needs, right? So a big thing here, or big quality of life that I like about this a lot, is that I can combine these instruments into one group and move them around and work with them all together at one go. So if I have multiple channels and I already know that I want to see a table, I want to see a scope capture, I want to see XYZ, I'll be able to have those channels configured for every single instrument within that group. Now, this doesn't mean that I've completely gotten rid of my individual features per instrument. I'll still be able to mess around with those properties. Now we've just added some more extra features to work with them as a group altogether. So to show you guys how to combine multiple instruments into one group, what I like to do, you can just select them. I like to just control and click and give it a second here. So I'll just hold control as I click the instruments that I want to group together. I'll go to my instrument property tab over here, and I'll see that I have this option at the very bottom to group my selected instruments together. So as you saw, I can dismantle or enable the grouping up to my discretion. And I have some more options here now that I have them all together in one group. We've also added a new file extension type for exporting the atfx file types, which is an ASIM compliant file type. I know it's very important for specific industries. We decided to add this along with all the other export types that we have here. So to show you guys how to do that, you go to your export settings tabs, and over under general, where you would normally have your format for your export, just like with the Excel, the CSV files, you now have an atfx file type here. One thing I do want to note is for this specific file type, you have to make sure that you have record compressed data files disabled to make sure that you'll be able to export successfully.
That's pretty good. So that particular file format was made strictly to help some of our customers, like a customer subset, like Malik was saying, to help them meet certain compliance constraints or certain compliance things that they had to meet. We like doing that. That's what we do. Oxygen is for the user, by the user. So we take your feedback. If you have a compliance thing that you have to adhere to, or if you have improvements that you would like to see made within Oxygen, we love your feedback. We build the Oxygen software around that feedback. So please do not hesitate. And don't forget that this works in both Windows and Linux. So if you want to run one operating system or the other, it has all the same functionality.
Mm-hmm. So some more additions that we've had, and just like Tyler was mentioning, a lot of these new improvements that we have that I'm going to cover has been really for the consumer, right? Oxygen is a very powerful tool, and having that ability to utilize all of that power very quickly in one screen is really important to us. So one thing that we've added in here, right, for the usage of the scope is now we have an offline mode for it and a live mode. So if I went to go and I wanted to capture my waveform through the trigger in live mode, it works as normally expected. However, now when I freeze it, I still have that standing waveform, just like you normally would with an oscilloscope. So I'd still be able to mess around in terms of my cursors, being able to really do my signal analysis that I may need while I'm in offline mode after I've captured a waveform. On top of that, we've made some improvements to the table tool. So normally when it's running, you'll see that I'm acquiring data continuously, but let's say I catch a data point that I really want to go navigate to, instead of having to export it to a CSV file and then go around to just try to find that one point. You can now scroll through in the measurement screen directly through the table to go look at that data point, making it very quick and easy to access this tooling. We've also added a new configuration for that output channel of your CAN signals. So normally whenever you have a CAN signal with a message, let me filter by CANs here so I can find one. There we go. Normally you'll have a signal with a reference input or a reference channel to it. Instead of having to go into the setup and then going to finding what channel I'm referencing here, we've added this new reference channel tab so that we can easily see what channels each of my signal is referencing. So if I have multiple CAN systems, right, CAN signals for a multi-system application, and I don't want to click through every single setting through them, I can now see that very easily here. We've also added some more improvements directly in the instruments themselves. So as you may be familiar with the instrument properties, I can go and mess around and with my functionalities of my instrument. Now, when you put your measurement screen into freeze mode, you'll see that I have these options here. These are like quick mode or quick access options for me to work directly in the instrument itself. So I don't have to keep going back and forth. If I really need to enable my cursors really quickly, I want to have, a specific type of markers, see what those values are, or, I just want to see what this peak is really, really quickly. I'm now able to do all of that directly on one screen. So really emphasizing on that aspect of ease of use, being able to take all the powerful features that Oxygen offers, but make it very intuitive and easy to access. And that'll wrap up for my updates on the new major release Oxygen 8.0 software.
Thank you, Malik. That was awesome. That was really well done. So, I mean, just to kind of do a quick recap. So we talked about XCP, right? The enhancements made to that protocol and just the overall throughputs. Like I was saying before, if you felt maybe it wasn't viable or just wasn't fast enough for you before, give it a shot now. That's a 200x improvement in just overall data flow. We talked about Skippy. So Skippy is a very powerful tool, and the library that we had helped to get a lot of things done that you needed to get done. But now we've essentially taken that Skippy library and just blown it up. Like, it's huge now. So especially when it comes to overall testing automation, like it's going to help out a lot. We talked about tagging and grouping. I love that functionality that we've added. It's going to make things a lot easier for folks to be able to group things together, especially when you are talking about your channels. Say you're doing a big test and you want to be able to just focus on one part of that test. You can set that up into subsystems, right side, left side, front, back, whatever you need to just make your overall workflow that much more efficient and work that much faster. And then the export formats. I've said it before, I'll say it again. Oxygen is for the user, by the user. We created that export format because a specific customer subset needed it. And if you have anything, any compliance things, any enhancements, any of that you would like to see just for Oxygen, don't hesitate to reach out. We love hearing your feedback. We take that feedback very seriously. And that's how Oxygen becomes what Oxygen is today. That being said, we're going to touch one more piece about the software that's also really cool. So we're going to talk about enhancements that we've made to our SDK. So our SDK, extremely powerful tool that, in my opinion, is underutilized. But essentially, Oxygen has a lot of power to it, a lot of features that are directly embedded into it. But what the SDK does is it essentially limits the functionality of Oxygen by your imagination. If you can think of it, you can code it, you can make the software do it. And this makes that a lot easier, because before there were a few different parts and pieces you had to mix and match and get together, along with your own compiler and all these other parts and pieces. But we've streamlined that whole process of getting that SDK up and running. And I'm going to have Malik share a little bit of what that looks like now.
Yeah, so we now have a new plugin wizard for our Oxygen SDK. So this has made it very easy for customers or users to navigate and utilize the SDK very quickly. If you use Visual Studio, right, you may be familiar with the option of plugins, right? We now have a plugin wizard, which is available on GitHub. You can download, you have Visual Studio installed with the C++ desktop development. You run the wizard, it sets up everything for you, and then you'll be able to create a new project using that plugin as a template. This will take care of all of the dependencies that are required, the compiler, so on and so forth, so that whenever you build it and you're ready to start coding, you have a nice template to get started from. with the combination of our examples there, it's become increasingly easy, lowering that learning curve for being able to utilize that SDK. And as Tyler mentioned, the beauty behind that is you now expand the horizons of your creativity and be able to really interface and utilize that powerful features that Oxygen brings right at your fingertips.
Very cool. All right. So Malik kind of hinted at it. We hinted at it at the beginning. We talked about big things that are coming. Well, big things are here. So we covered some of those with our hardware and our software, but we got one additional piece that I'm super excited about. And we're going to play a video for y'all to get an idea of what we got coming or what's here for you already.
Every data acquisition starts with a final check of your measurement setup. That's why we developed Oxygen Go for you. It is the mobile app of our measurement software, Oxygen. Oxygen Go enables seamless connectivity from a mobile device to Oxygen running on any DEWETRON data acquisition system. It's a deal breaker when your device under test and your testbed control system are located separately. Preview analog hardware channel data, review channel settings, and modify them immediately if necessary. Start, stop, or pause your recordings remotely. Oxygen Go. Level up your data acquisition. Download Oxygen Go in the App Store or Google Play Store now.
Right, so as we can see there, we have finally officially released our mobile app. So this mobile app is super powerful. It allows you to make direct configuration changes to your channels. It allows you to view the data. It allows you to start recordings, stop recordings, and it puts all of that at your fingertips from your phone or your tablet, whatever you need or whatever you're working from. So perfect example. Many of us have done these long multi-day tests, right? But we can't be at the shop or 24/7, right? So what's one of the fears that we have? Well, something's going to happen at 12 o'clock at night. I'm going to get a call and they're going to have me come in and fix something. Well, now as long as you can connect to that system, whether via VPN or whatever else, you can actually do that straight from your phone right there. No coming back into the office, all that hassle that maybe have been there before, or for remote tests, right? So the system's sitting in a totally different area, or maybe a confined area that's officially been locked down and you no longer have access to. This allows you to be able to start that recording, stop, make any of those changes. All of that's available for you right there at your fingertips. So I would encourage everybody here on this webinar to go to the Google Play Store, go to the Apple Store, and go download this app. This will work right now with your Oxygen system. So Oxygen version 8 makes it easier because Oxygen 8, for those of you who may have caught it, there was a QR symbol in the screen that Malik was showing as he was going through the Oxygen features. You can simply just scan that with the app, and it'll immediately put all the data or all the information that you need to be able to connect to that system and allow you to do everything that you need to do. So really cool stuff there with that. I mean, I'm super excited, and I think this just makes the Oxygen software just that much more powerful. So that being said, let's see if we got any questions here in the chat. All right, can Oxygen Go be used to receive alarm conditions? So you get all that information. So those alarms that you set with your math channels and everything, you get all that information in because it sees that as a channel. Another question. So how much does Oxygen Go cost? Well, Oxygen Go is free. That's why, again, I encourage everybody to go out there and get this, try it out, and let us know what you think. I mean, like I said before, for the user, by the user. So if there's enhancements you'd like to see to the Oxygen Go app, let us know. We just released this. There may be some things that we didn't think about that would be useful to all of you. So let us know. Any more questions that we can think of, folks? Does the DEWETRON system need to be connected with the internet? So the DEWETRON system just needs to be on the same network that your mobile device is connected to. And from there, it's initiating SCPI commands back and forth with the system to be able to get that data, look at it, and make those configuration changes. Essentially, what we've done is we have capitalized off of that increased SCPI library that we've created with these new versions of Oxygen.
Yeah, it is a local network connection. So, I mean, typically Wi-Fi is the easiest one, but theoretically it is possible to connect via cable, albeit that, you might not want to. I do know that some people might have security concerns. So I did confirm that if you really, really do want to, you could reach out to us and we could look into that for you. The important part is that it's connected to the same local network, whichever one that you decide to go with.
All right. Thanks, Malik. So call to action. Anybody who likes what they saw with these latest enhancements to Oxygen version 8, reach out to us. Let us know. If you didn't know already, anytime you have a major revision of Oxygen, all minor revisions within that major revision set are at no cost to our customers. So reach out. Let's get you on the latest and greatest version of Oxygen, get you access to all those cool features that come along with that latest and greatest. And please go out, download the app, download Oxygen Go. Let us know what you think. Okay, so I think that pretty much covers everything that we had for our presentation today. I'd like to thank everybody for making the time to attend our webinar. Appreciate everybody's time. And if there are no more questions, we can call this done. All right, everybody. Have a great evening. Have a great rest of the day and have an awesome weekend.